Hello, and welcome back to this YouTube channel, Math and Science Problems. Today, we will be going over and explaining distance, rate, and time. Before the video starts, I would like to give you all this moment to like, share, and subscribe. Comment down below if you have any questions, concerns, or comments in regard to the video. With that, let's begin. So, you may have been wondering, what is distance, rate, and time? Distance is, or can be, whatever you want. It can be meters, it can be centimeters, it can be inches, yards, it can be anything. Time can be anything as well. It can be seconds, it can be hours, it can be nanoseconds, any unit you want, that's what it can be. So that's pretty much what distance and time is. It's pretty much how far, which is right here, and then it's the time. So seconds, hours, minutes, nanoseconds, milliseconds, anything that you would like it to be, which is right here. However, what is rate? Now, rate is pretty much taking the distance and dividing that by the time. So that could be viewed as the equation d over t is equal to r. Now, rate is equivalent to distance over time because rate is pretty much the constant linear, equation to how something is moving or being processed. So if I were to say I run 10 meters in 2 seconds, SEC is short for seconds. Now, dividing this, usually we have specific units compared to time. So if I was driving a car 60 miles per hour, the units would be miles compared to hours. Miles being the distance and hours being the time. Now this varies. Understanding distance, rate, and time, where 10 miles is the distance and 2 seconds is the time, we can view this in many different ways. Specifically, just for this moment, we can understand that the units can be corresponded in different ways and are supposed to be used in different ways, such as miles per hour, where per is equivalent to 1. Miles per hour, if you're running a mile, miles to minutes, most likely. Kilometers for metric units. It all depends on what you're measuring. But for right now, we're using a hypothetical situation, so units don't necessarily matter right now. However, the concept is still there. So when we're dealing with distance and time, and we're trying to find the rate, we simply divide the two. So we are given 10 divided by 2, which is 5 miles. And since we want to use per, which is that 1 right now, we do that in 1 second. So we run 5 miles every 1 second. Now this is known as the rate. And this can be solved in many different ways for the rate, but this is one of the most common ways to solve it. Now, let's backtrack a little bit here. So, understanding that we found the rate using, whoa, so sorry. understanding that we found the rates using this specific format, d d over t is equal to r, which is the rate. We can use multiplication or simple algebra to figure out the other corresponding variables. So if I wanted to find the distance, I would simply do distance is equal to t times r by simply just timesing the times on both sides, which allows me to isolate the d or distance variable. If I wanted to solve for time, I would simply multiply time or the t variable on both sides, and then I'm left with 1 over t. Let's do it up here. 1 over t. So sorry, hold on. So if I wanted to solve this, I'll multiply by t by both sides. So I'll be left with t times d is equal to r. R times t. The t's cancel out on the left side, right here. And then I'll divide by r because I'm inversing the multiplication aspect. And then I'm left with d over r to solve for the t variable. So now that we know the formulas to find respectively distance, time, and rate, we can try this for a math problem. So let's say Tom ran 20 miles in, let's say, 4 minutes. It's pretty fast. MIN for short. So let's say Tom ran 20 miles in 4 minutes. And now let's try to find the rate for this. So since miles is known as the distance and minutes is the time, we would simply do 20 divided by 4, which is 5. And we will be finding the miles, so 5 miles in 1 minute. And you would always want your time variable to be in 1 unit because you want to find it per whatever it is. Hello. So I went ahead and did a little bit of work. It's like a big kind of transition. But I wanted to show you the perspective of distance, rate, and time in terms of a graph. So in the graph, of course, we have distance, rate, and time. Now, when we're understanding distance, rate, and time, we can understand it in many different ways, but the graph is one of the most visual ways you can understand it. So right here, when we divide the distance by time, that's how we get our rate. Now, for the different equations, distance is equal to rate times time, rate is equal to distance divided by time, and time is equal to distance divided by rate. Now, when we look at this from a graph perspective, where d is equivalent to y, or you can be viewed as the y-axis, and t, which is the time, can be viewed as the x-axis, we have, respectively, we have a y and x axis coordinate plane. Now, this black line right here, which you see with the orange arrows, so the black line with the orange arrows right here, this shows the corresponding units if we were given distance and time. So, say I was driving 60 miles, or I was driving, whatever it could be. I was driving 60 miles, and this is it in 1 hour. And from this graph, we have this point. Let's just say this is 30. And from this, we make this point right here. And this point right here, this blue dot right here, this is the rate. And this is the rate because when we divide our distance by our time, this is the solution that pops up. So we can understand this in many different ways. Not only are we able to understand this in just this setting, but we're also able to understand this to find the different variables. So say I'm given the rate of a word problem or whatever it can be, and this blue dot is my rate. I'm able to find both the distance and the time because if I'm able to draw the lines, I can see that through these x and y, these 2 points, they form that connection at this point on this linear line, which is how, if you're given the rate of any equation, you're able to revert back to both the distance and the time, and inversely, the distance and the time can get you the rate. So, looking over here, we can understand this black line with these orange arrows as y equals mx plus b, where b is the y-intercept and m is the slope. Now, right here in our bottom right corner, our slope is just as equivalent as to rate. If I'm driving or anything is like 0.75x, that's the same thing as the rate. So the rate and the slope are essentially the same thing, which is why we can correspond it to a linear graph, y equals mx plus b, right here, and why we can consider y as distance and x as time. Now, understanding this in other views, just for fun, we can see that this orange line right here just resembles that we could have a negative line that still corresponds to a linear path. It's just that it's flipped the opposite way. So if I were to run 60 miles right now, and if I run 60 miles in 20 minutes, how many miles will I be behind that positive, I guess, growth if I were to start at a previous time frame, which could be symbolized by this graph right here. But in our other graphs, like this blue exponential one right here, and this orange parabola, and this green logarithmic function, these three different functions are all symbolic of growth. And when we were taking specific points off the x-axis to find this specific growth in a function, we can use d of x, which is also known as the derivative, which is a calculus concept, but it can be somewhat corresponded into this lesson because we are talking about distance, rate, and time and how that corresponds to a graph. So when we're understanding this, we can see that d of x is essentially just distance of x per point. So I'll say this is 1, 2, and 3 respectively, and I want to see where the distance from this point right here, from 1 to 2 on this blue exponential function, I could use the derivative to calculate that. So this is just a point of growth to understand how this can be implemented into this concept of distance, rate, and time.